Exam 3 review, I'm probably going to have to do this video in 2 parts, so this will be part 1. If the following is a polynomial function, then state its degree and leading coefficient. If it's not, then state that fact. Is this a polynomial function? What's the requirement in order to have a polynomial function? All of the powers on x have to be what? Positive integers. They can't be fractions. So is this a polynomial function? What is the degree of this polynomial function? The degree is the highest power on x, and then what's the leading coefficient? The leading coefficient is the constant that the highest power of x is being multiplied by. Is this a polynomial on number 2? Why is it not a polynomial? Good, because that power on x is a negative. On number 3, you're asked to determine any local or absolute extrema as indicated. Use the graph of f to estimate the absolute extrema. So do we have any absolute maximums? Remember, there's assumed to be an arrow going here, so I'm not going to have an absolute maximum. Do I have an absolute minimum? I have absolute minimum values right here, so I have an absolute min of what value? At x equals plus or minus 2. Do I have a local maximum value? This would be a local max of 0 at x equals 0. Do I have a local min? These absolute mins are also local mins. But if they're absolute, we're going to say that that's it, it wins. On number 4, the instructions are the same to determine any local or absolute extrema, but now I don't give you a graph, I give you a function. But you know how to graph this quadratic function from chapter 3, correct? Where's the vertex on this quadratic function going to be? -3 and 1. So I go to -3 and 1 and I put a point for my vertex. Will this quadratic function open up or down? It opens down because that leading coefficient is positive, which means that the graph is going to look something like this because it's going to be taller and skinnier because of that 3 right there. So do I have any absolute maximum values? I have an absolute maximum of what? Of 1 at x equals -3. Do I have any absolute minimums? No, because these arrows keep going down forever. And do I have any local? The absolute max pulls double duty as a local max, and I don't have any local min, so we're done with this problem. You've got to remember everything you ever learned in this course. If you've learned how to graph quadratic functions using transformations, I'm assuming you still remember that. Remember, your final exam is cumulative, so you don't want to forget anything ever. Number 5, we're asked to use the graph to determine if the function is odd, even, or neither. Is this function even or odd or neither? It's odd because we have symmetry with respect to the origin. If we were to flip this graph upside down, wouldn't I see the same thing? So if I rotate this graph 180 degrees, if I were to flip this picture around, I would still see the same graph. Now what about this graph? This would be even because we have symmetry with respect to which axis? Symmetry with respect to the x-axis means if we flip it across the x-axis, the top half and the bottom half would lie on top of each other. They don't. If we flip this across the y-axis, the right half and the left half would match up. This one's odd because if I have a point xy on the graph, I'm going to have a matching point -x, -y on the graph. No, it's increasing because it does that. It's not odd because it starts down here and goes up. If you have a point xy on the graph, you're going to have a matching point at -x, -y. On an even function, if you have a point xy on the graph, you'll have a matching point at -x, same y value. Now, if you don't have a graph and you just have the function, how would you tell if a function is even, odd, or neither? Nope. You replace x with -x. Odd functions, you get the opposite function back. Even functions, you get the same function back, and you would neither get the opposite or the same function back when you replace x with -x. So to determine if this is even, odd, or neither, what I would look at is f of -x. So here I would replace x with -x, and that's going to give me -3 times a negative cubed is a negative, and a negative times a negative is. So this is going to be 3x squared, and positive 6 times -x is -6x. Is this the same function that I started with? It's the opposite of what I started with, so this function is odd. So here when I replace x with -x, I get 2 times -x squared minus 4. What happens when you square a negative? Is positive. So this would be 2x squared minus 4. Is this the same function that I started with? So this is even. And on 9, when we replace x with -x, we get negative 7 times negative x to the fourth plus 5 times negative x minus 4. I replace x with negative x, and what happens when you raise a negative to the fourth power? It's positive, so we get negative 7x to the fourth, and a negative times negative is positive 5x minus 4. Is this the same function that I started with? No, because that middle sign changed. Is it the opposite of what I started with? No, so this one would be neither even nor odd because it's not equal to the same function and it's not equal to the opposite function. So if I give you an equation on the test and I ask you, is it even or odd or neither, what you need to know that means to do is replace x with negative x and see if you get the same function back or the opposite function back. Remember, the O's go together. An odd function is symmetric with respect to the origin and you get the opposite function back. Odd, opposite origin. The even function, you get the same function, and an even function is symmetric with respect to the y-axis. Any questions? On number 10, we're told that the graph of a polynomial is given. Identify the degree of the polynomial, the turning points, and any x-intercepts. Also estimate any local max or min and any absolute max or mins. Okay, so here's the y-axis. Here's the x-axis, and it looks like the lines on x represent a unit of 1, but the lines on y represent a unit of 2. That's important. What would be the degree of this polynomial? Here's our polynomial right here. We've got 1, 2, 3 turning points, and both of the ends point in the same direction. The minimum degree here has to be 4. It's 1 more than the number of turning points. Plus, because it's an even degree, that means our endpoints are going in the same direction. Now we need to identify where the turning points are. And I have 3 of them. There's 1, 2, 3. So I have a turning point at negative 3, negative 16, 0, 0, and 2, negative 6, it looks like. X-intercepts. I have an x-intercept here, here, and here, so that would be at x equals negative, it's close to negative 4, 0, and 3. It's close enough to negative 4. I would take negative 4. Do I have any local max? Yes, I do. I have a local max of 0 at x equals 0. Do I have a local min? What is my local min? I have a local min of negative 16 at x equals negative 3 and negative 6 at x equals 2. Do I have an absolute max? I don't have an absolute maximum value because there's not a highest point. What about an absolute min? I have an absolute minimum of negative 16 at x equals negative 3. And that's how you would read the graph. For 11, 12, and 13, we're asked to state the end behavior of the graph. So here's the function. We know that our endpoints are going the same direction or opposite direction. What do we look at to determine the end behavior? The power if it's even or odd, and if it's odd, they go in opposite directions, and also the sign of the leading coefficient. So our endpoints are going to go in opposite direction. Will they look like this, or will they look like this? The first one or the second one? Why the second one? Because of that negative right there. You start at the top and work your way down. Remember, I said negative people can start at the top and they'll always find a way to work their way to the bottom. Odd is opposite direction. So they're going to be going down. We're going to go up on the left and down on the right. That's the way you would read this. On this one, will my ends go in the same direction or opposite direction? We go in the same direction because x is raised to an even power, and they'll be going up or down. Down because a negative leading coefficient, so they're going to be going down on both sides, and that would be A. On 13, we have an odd power, so will our ends go in the same direction or opposite direction? Opposite directions, will they go like this or like this? The first one, because positive people start at the bottom and work their way up, so it's going to look like that. So we'll be going down on the left and up on the right. You need to have that endpoint behavior memorized. 14 says to pick which graph satisfies the given conditions. So we have a polynomial of degree 3. What does that tell us about our end behavior? Same or different directions? Different directions, because we have an odd degree with 3 distinct real zeros. That means we're going to cross the x-axis 3 times, and we have a positive leading coefficient. that we're going to have two turning points, but what does that positive leading coefficient tell us? Start at the bottom and work their way up. So could A be? Why not? It doesn't have three distinct real zeros. The shape is right, but it only has two zeros. What about B? B only has one zero. What about C? No, because it's decreasing. That'd be a negative leading coefficient. The answer here is D because we have the right shape and we're increasing. So this is going to be D. On 15, we have a polynomial of degree 4. What does that degree 4 tell us about our endpoints? They're going in the same direction with two distinct real zeros. Oh, and we have a negative leading coefficient. So is it going to smile or frown? It's going to frown, so it's not A. And could it be B? Do we have two distinct zeros and a negative leading coefficient? Yep. Does this look like a fourth degree? Yeah, it looks like it could be because we've got this little kind of like turning point right here that's not real pronounced. Could it be C? Why not? There's no real zeros. Could it be D? D looks like a possibility because it's got two zeros. This one has two zeros, but the shape here on B looks more like a fourth degree than the one on D. D looks like it might be a quadratic. So we're going to go with B. Do you see the difference, the logic that we go through? All right, so we're going to evaluate this function at the indicated value. These are the piecewise functions. Remember, these are like three different functions over given domains. So on 16, we're asked to find f of 7 for this piecewise function. 7 determines which of these three functions we're going to use, this one, or this one. Is 7 in the first, second, or third domain here? Is 7 less than 0? No. Is it between 0 and 6? No. Is it bigger than 6? Yes. So to find f of 7, I look at this third function, so that's going to be equal to 7. On 17, we're asked to find f of 5, so I've got to determine which of these three functions I use based on where 5 falls in the domain. Is 5 less than 1? Is 5 between 5 and 10? Yes, because x can be equal to 5 here. So f of 5 will be equal to this, using this function, that would be 5 times 5, and 5 times 5 is 25. On 18, which of these three functions would I use? The first, second, or third function if I want to find f of negative 8. Is negative 8 between 8 and 11? But negative 8 is less than 8, isn't it? So I use the first one, so that's going to be 9 times negative 8 plus 1, so that's going to be negative 72 plus 1, and that's equal to negative 71.